This circuit starts with 9 volts and ends with almost double that. No transformer. No IC boost module. Hey guys, in this video, I'll show you how to make a voltage doubler with a 555 timer and a few components. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 2 alligator clips, 7 jumper wires, 1 33 kilo ohm resistor, 2 1N4004 rectifier diodes, a 9-volt battery buckle connector, a 9-volt battery, 1 555 timer IC, 2 22 microfarad capacitors, 1 10 nanofarad ceramic capacitor, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and astable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 2 or trigger to pin 6 or threshold. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. Insert a 10 nanofarad ceramic capacitor into pin 2 or trigger on the negative rail. Bend the ends of a 33 kilo ohm resistor. Insert a 33 kilo ohm resistor into pin 3 or output in pin 6 or threshold. Insert a 22 microfarad capacitor into pin 3 or output and a few rows below the 555. The cathode is in pin 3. Insert a jumper wire into pin 8 or VCC and a few rows below the 555. Insert a 1N4004 rectifier diode into the same row as the jumper wire and the 22 microfarad capacitor. The anode is in the same row as the jumper wire. Insert a 22 microfarad capacitor into the same row as the diode and the negative rail. The anode is in the same row as the diode. Insert a jumper wire into the same row as the diode. Attach an alligator clip to the other end of the jumper wire. Insert a jumper wire into the negative rail. Attach an alligator clip to the other end of the jumper wire. It's time to connect the power supply. Connect the 9-volt battery buckle connector to the 9-volt battery. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. Now comes the moment of truth. Let's put a multimeter on the alligator clips and see what voltage we're actually getting. Attach the black alligator clip to the black probe. Attach the red alligator clip to the red probe. The reading measures approximately 16 volts, which is close to double the input voltage from the 9-volt battery. Let's dive into the circuit and break it down step by step. This circuit is a 555 timer-based voltage doubler, and it works by converting a DC supply into a fast switching signal, then using diodes and capacitors to pump charge to a higher voltage. Think of it as a two-stage system. First, the 555 creates an oscillating square wave, and then that square wave drives a charge pump voltage doubler. The 9-volt battery powers the circuit through pin 8 of the 555, while pin 1 is connected to ground. Pin 4 is tied directly to pin 8, so the chip is always enabled. The 555 is configured as an astable oscillator, meaning it continuously switches its output high and low. This oscillation is set by resistor R1 and capacitor C1. Pin 2 and pin 6 are tied together and connected to the timing capacitor C1. As C1 charges and discharges through R1, the voltage at pin 2 and pin 6 rises and falls between 1/3 and 2/3 of VCC. Each time those thresholds are crossed, the 555 flips its output state. The result is a square wave at pin 3 that swings close to 0 volts and close to 9 volts. That rapidly switching output is the key to doubling the voltage. The right side of the circuit forms a charge pump using two 1N4004 diodes and two capacitors C2 and C3. When the 555 output goes high, current flows through the first diode and charges C2. When the output goes low, the stored charge on C2 is effectively stacked on top of the supply voltage through the second diode, pushing current into C3. Over many cycles, C3 accumulates charge to a voltage that is roughly the sum of the supply voltage and the voltage stored on C2. During one half of the cycle, the circuit fills C2, and during the other half, it dumps that stored energy into C3, while adding it to the original supply. This is why the output capacitor C3 can reach close to twice the input voltage. With a 9-volt supply, you'll typically measure something around 15 to 17 volts at the output, not a perfect 18 volts. The loss comes from diode forward voltage drops, internal resistance of the 555 output stage, and the fact that this is not a regulated supply. The diodes ensure current only flows in one direction, preventing the capacitors from discharging backward when the output switches states. C3 acts as a smoothing capacitor, reducing ripple and providing a more stable DC output. However, this circuit is only suitable for low current applications. As you draw more current from the output, the voltage will sag, because the charge pump can only move a limited amount of charge per cycle. This circuit is a classic demonstration of how a 555 timer can be used not just as a timer, but as a DC to DC converter driver. It shows how switching, timing, and basic diode capacitor networks can work together to produce a higher voltage from a lower one, using surprisingly few components. I hope this video has shown you how to make a voltage doubler circuit with a 555 timer. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Just click the link in the description to download your copy now. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.